guy. Okay, REST microservices with the KISS Web Development Framework. So the KISS Web Framework is an open source framework on GitHub, one I wrote, and one of the many things it does is REST microservices. So and that's kind of what my talk is about today. What is a microservice, REST, all that stuff. So let me see. What is REST? It's a method of communicating data between the front end and back ends. Because you know you have a browser and then you have a back end, and the way those talk, there's several different methods of talking, but REST is one of them, and that's what's kind of like the most popular. And it normally does JSON, but REST is not restricted to that, but that's just what's commonly used. Also, another cool thing about it is it uses port 80 or port 443, you know, so people don't block it. Because if they use special ports to do these communications, then what happens is companies block the ports and you can't get through. Also, REST is stateless, which means that essentially every call you have to verify the call. You don't just accept calls from anyone and anywhere in the world. And then, like I said earlier, mainly uses JSON. Uses JSON because, as you know, browsers talk JSON, so it's convenient to use JSON on both sides. What are microservices? So first of all, microservices exist on the back end. I suppose there might be some way to make it on the front end, but I'm not sure what the value there would be. But what it does is, you know, some of these systems, like I downloaded Chrome earlier today. No, it was IntelliJ, and it was like 100 megabytes. So you can imagine how big the source code is. One of the systems I work on daily has 10,000 classes. So it's huge, and so how can you figure out if this thing was spaghetti code where this is calling that? You'd never be able to maintain it. So what they've done is they've kind of encapsulated everything. You try to have all your functionality for a particular area in one place. So when someone calls me with a problem with my own system, they go to help and about, and it tells me what screen they're on exactly, and I know where the microservices are for that screen. So I can find the code in 10,000 classes in 2 seconds. It's very easy to maintain. So that's one of the things. Another good thing about is it's easy to develop with. So you don't have, if someone says they want an enhancement or something, you don't have to put code in here. You just write one little section for what you're dealing with. It keeps everything a lot easier. Then some of the advantages of the KISS system, which I use, is that there's no wiring or configuration. So in my system, you don't configure and say, okay, I added a new service here, you know, put this in the XML file. I don't have any of that. You just drop the file in place and it recognizes it and it goes in there. Also, there's no compiling on my system, so you can change while you're developing. You just save the file and boom, it's right there. And everything runs at full speed because it actually compiles it at runtime. So it detects the fact that you changed the file and it recompiles it. So there's no cost there. Also, if you have a production system and you have 500 users and one area is messed up, all you have to do is fix the code and drop the file in place. Boom, the system automatically detects the fact that it changed, it recompiles it, and runs the new code the next time. So that's some additional features of KISS over what are regular microservices.
And it seems to be not auto-advancing right now. I don't know if you had hit stop
Okay.
or something, so you have about a minute left.
Oh, okay, I'll hurry up.
Your whole time.
What is the KISS? It's a free open source development framework that I mentioned before. It's on GitHub. GitHub. Anyone can use it. It includes not just web services or microservices or any of that. It also includes front-end framework, authentication, being able to save the data with SQL, report generation, all that kind of stuff. So basically, you can write a whole. When you download it, you can have it running in one line of code, and then while it's running, you can actually modify your app. So let me. Why did I do KISS? Well, I just, when I started getting involved with web applications, there was just nothing. There's just a lot of great tools, and they're all complicated. And then you can't make an app with them because you have to integrate all the different pieces. And then what happens is by the time you get through integrating it and figuring it out, they start changing. So then you want to upgrade, oh shit, that broke this API. And it becomes a full-time job keeping the thing together. and it was just too complicated for me to use. I need something that was all one piece, all worked, very simple. And I have a lot of years building frameworks like this, so it was something that wasn't impossible for me to do. I'm using everything's standard stuff. It's Java, HTML, JavaScript, SQL. I don't have any cockamamie languages in there. And it's also portable Linux, Mac, Windows, fully compiled, as I mentioned before, and I don't know what that last line says. Oh, well tested, yeah, there's some production systems using it today. So it works well. Okay, so I'm showing you now a real web service.
And then we got to figure out on the time because you're at like 5.5 minutes right now.
Okay.
So I don't know if you can. I don't know how much time we have because we want to make sure we get through everybody because we planned about 5 minutes for it.
Okay.
And the slides didn't seem to be auto advancing for you. So
Okay.
I don't know. We can give you a couple extra minutes and then.
Okay. So this is the front end code. So this is just plain JavaScript. So you create a Java thing, you pass it in, and you get it back. So that's how simple it is in the front end. The back end code, this is an entire microservice. There's no other code except for maybe a package statement on top of it. So you just say class, and the class becomes the web service, and the method becomes the web method. And then the arguments that are coming in come in on every single one, and you can just get the input, and you seem to be putting an output. Questions? Yes.
How long did it take you to develop it?
It's been in continuous development for maybe 4 or 5 years.
Oh wow, okay.
Yeah. So what happened is I had a need for it and just started making pieces and pieces, and then at some point with that system that had 10,000 classes. And then at some point I just said, I could just generalize this and call it out, and that's what I did. And then since then a bunch of other apps have been written with it.
How are you doing service-to-service communication?
How am I doing authentication?
Set up
Service-to-service
next one.
communication.
I'm just gonna set up the next one while you
Oh,
answer
okay.
questions.
Service what?
Service-to-service communication.
Oh, it's just REST, plain REST, port 443 usually.
So you go down, I see.
Yeah, so it's standard REST. I don't mess with it. Although there's a couple of things that I do that are interesting there. One is they're asynchronous services, which means if the server's busy, the front end will wait for it. And the second thing is that I use a thread pool, which means if you have 10,000 users coming in, you're not going to just kill the server. It'll use up 40 threads, and then it just puts them on a queue. Any other questions? Thank you very much.
All right, let's see if we can get this one to autoplay correctly. All right, so I'm doing a presentation on using AI to write a presentation. And so the whole presentation was actually written, or most of it, written by Bard or ChatGPT. The photos by Google, and these are the titles that ChatGPT came up with for the presentation. So which AIs am I using? So I'm actually using Bard, which you haven't used it. It's Google's version of ChatGPT. You can basically do the same thing. And then ChatGPT, which most people have heard, is from OpenAI. So those are the two that I have used mostly in here to do it. So the prompt that I actually did is, can you write a humorous presentation about writing a presentation using ChatGPT? So it's kind of like a basic one, and one of the key things is like, well, what prompt do you use to try to get your talk? So the problem is, this is what I came up with. Was slide 1, how to write a presentation using ChatGPT. Subtitle, easy way to get a laugh, maybe you learn something. If you just read through it, it's like very bland and very boring. There's not really much there. And I kind of said, hi, I'm your name. I'm your name. The other problem is it actually said slides 9 through 19. These slides can be filled with even more humorous examples of things that ChatGPT has generated. I was like, no, I'm trying to be lazy and have you write it. You can't just say slides 6 to, no, the other one did 6 to 19. So the first one was Bard. ChatGPT's version was kind of similar. Introduction. If you kind of read it, you can kind of see like there might be some humor in it, but it's not a very good humor, or it's kind of like just, you kind of go through it and you're like, it doesn't make sense. And so I actually asked Bard, like, would it be better to use you or ChatGPT for the presentation? It says, I'm a text-based AI, and that's outside of my capabilities. I was like, really? It can't even decide whether or not it's better or not? It just reminded me of 2001. ChatGPT answers like, well, since September 2021, there's no model that I know of called Bard, but assuming it is, and then it proceeded to give I think like 12 bullet points of full text of why it was better. So I think Google needs to at least, do a little bit on that. This is another slide that I came up with, is like the brainstorm buddy. Need ideas? ChatGPT's got you covered. And so this actually, the bubble or the picture here is like a person who has more ideal bubbles than socks. And I don't know where the socks came from. So how do I do it? Well, so there are a bunch of generate you can do for images too. So there's DALL-E, there's Midjourney. Some of those can do pretty good. They actually are more paid versions right now. The one I actually used is the one on the right you can see, which is Help Me Visualize. So I said unicorn holding a pencil, kind of got that. Cat wearing a funny mask. It's supposed to be a mask, I'm not sure what it is. And mushroom drinking tea, which kind of looks like a sloth turned into a mushroom or something. I mean, they kind of fit what it is. So if I just did a web search, this is what I got for a web search. Unicorn holding a pencil, cat wearing a funny mask, which my daughter said, no, you have to pick that one's really cute. And then mushroom drinking tea. So you can kind of see, like, just by doing image search, you can kind of get a certain set. Another slide is like the research whiz, and this is literally what it said. It says, no more trawling. Just don't blame us if it references obscure conspiracy theories. That was literally in the slide that ChatGPT gave me. So I think it's pretty, you want to make sure you actually check it. You can do amazing stuff that you can say, can you rewrite the presentation in the style of William Shakespeare? And it came up with this amazing stuff, which I wouldn't be able to do. 'Tis not but scribing alone, ChatGPT canst refine and polish thy script. So it's good for being able to do that kind of stuff. But again, you can kind of see, like, if you're reading this, the humor part of it isn't really something that would be if you had someone actually sit down and write it really humorous. It's more of kind of like, you're like, I guess that could be humorous, but it's more of like a very kid humor or something else. So what's the future for it? Well, it's great for some things. It will definitely get better, but you really need to know what it can be used for. And then you also really want to check your results. That's one of the key things. Like, whatever you get out of it, just don't submit into the law and hope it's right. So I actually decided to use it for, I started a meetup group that we do Puzzle Pints. So I said, write a description for a meetup.com group, gets together and does all this stuff. And then I actually had it kind of generate, what would a logo be like for a puzzle group that does these things? And it actually came up with a pretty decent, description of it. That required some editing because it kind of stated some stuff that I was like, no, that's not at all what that means. But I was actually impressed by the level of it and kind of gave me something to go for with being able to start it. So, and then this is actually the slide that came up for Q&A, which is time for Q&A. Go ahead, ask me anything. Just remember, I'm not powered by ChatGPT, or am I? So it actually really was written by ChatGPT. So, any questions that people have about and I might use ChatGPT to answer. No.
It seems like you prefer ChatGPT over Bard based on.
Some of it I'm using Bard too for a lot of it. So, but they're very similar in terms of the output that they actually gave. So I haven't really noticed a difference between the two of them. Both seem very well at being able to do that.
Okay.
I just said ChatGPT more as like people know what that is rather than the specific. Yeah.
Yeah, I got a question about all the releases. I was hearing a podcast that sometimes the predictive AI is getting so good that during the release, they don't know exactly what the version's capable of. Do you know if they're gonna just continuously update, like every time people find new things, continue to update the features, or how that plays? Because they say it's a little bit scary these days.
Yeah, I mean, there's a bunch of really good writings you should read of kind of like, what is it really good for and what does it actually do? Because a lot of it, they have no idea what it is because they train it and then it's all a mystery. There's kind of like this big model that they can't really inspect or find anything about and can't really tell, like, where did you get this from? It's like, well, these 12 billion parameters. So it's hard to, like, they can't even tell where it came from, and that's part of the problem of it. So it's really not meant to be an authoritative, exact truth-finding stuff, but more of, kind of like autocomplete for text or really predictive, and it's really good for that.
Get a really good sense of how that works when you get into a full self-driving Tesla and it doesn't handle something as well as it did the day before because of an update.
Yeah. I'm just not sure if companies will be, do you guys know if they'll be continuously updating what it's able to do? So let's say I start using, I don't know, like current version 4.0,
As far as I can
Yeah.
tell, you're just gonna have to try playing with it and
Okay.
seeing what you can get out of it. Cause
But they're not gonna update and say, hey, these are some updates on what we've learned at this version can find.
All right,
this
let's
is gonna be
turn it
good.
over.
Okay, ready?
Right.
It is gonna go every 15 seconds. Okay.
So hi, I'm Chase. I've been developing native apps for 5 years and currently working at Ramsey Solutions. Just to show you how easy this is, I was an electrical engineer in my previous life and started learning mobile development. So don't worry if there's stuff in this slide deck that you think is interesting. There'll be a QR code at the end that's got links to all the information.
It's a long 15 seconds.
So how do we write native apps? We use Android Studio and Xcode. Those are our IDEs. We use the Jetpack Compose and Swift UI as our framework, and Kotlin and Swift as the base languages for those. A little bit about how it works. Declarative UI, going from that example back there, you can obviously see that one is much simpler than the other, and that's the declarative UI benefit there. So some of those benefits, automatic light and dark mode support, easy accessible font sizes, because that comes by default. Speed of development, because you don't have to write super custom components for everything you do. Moving on to state management. State is actually very simple. As you can see, the one over there on the left is Android, and the one on the right is for Swift, so any of the Apple products. They're very similar, minus a few keywords. So those are screenshots of what we're going to build today, both apps in iOS and in Kotlin. Just a basic app that lets you move a slider to try to guess the value. So we start by first in Android Studio, we'll do Android first, creating a new empty project. And then from there, we actually will move into the basic layout of the code. It's a little bit hard to see, sorry about that. But that just lays out the basic components, just our text, our slider, and our button with some simple to-dos for adding state later. So here's some of the actual state management that we're creating in Kotlin. Up at the top, we are creating the instances there, and we are implementing the instances down on the bottom of that screenshot there. So as you can see, we're just adding the state logic. And then same thing right here, just adding scoring logic into our button, so that whenever we click the button, it will calculate your score, generate a new random number, and then reset the slider back to the center position. And then that's it. That was all it took to build that app in Jetpack Compose. Very simple. So now we'll move on to doing the same thing for iOS. So in iOS, same as we did in Android, we start just by creating a new project, and we just want to tell it that it's going to be an iOS app. We specifically picked the Swift UI language just because that is extremely similar to Jetpack Compose. The same thing here, we've got our basic view layouts with the standard text, slider, button, same as we did before in Jetpack Compose. Just some placeholders for the state. So adding state, as you can see, adds just a little bit more code. Like all of that code right there is what it takes to add state and make a semi-working app without all the scoring logic in it yet. Moving on to the next slide though, you'll actually see the scoring logic here. So same thing, whenever we click the button, we are updating the score, choosing a new random number, and then resetting the slider back to the center. Nothing very complicated. When you combine all those together, the iOS app is done. And as you can see, like it's very, very similar between the two, as far as code-wise, layout-wise, so on and so forth. We'll actually show an example right here of the side-by-side. So like the top over there on the left is actually iOS, and the top on the right, or the right side is Android. Looks like one of those TV sites. But anyway, there we go. So if you want access to all those code files, you can scan that QR code there, and it will take you to the articles where they are talked about in more details.
Any questions for?
Which
What you got?
How much code was generated by ChatGPT?
No code. What's yours, Kevin?
Let's say, which do you actually prefer to write in Swift or Kotlin?
I prefer Swift, but they're very similar. And then you had one?
Are you typically focused in one area, or are you typically doing both? Or are you doing both at the same time? Like, how does that work typically? Kind of having both.
Right now, I'm doing both at the same time, plus the back-end service. So,
Okay.
yeah,
Okay. You just have them like side by side? And
Yep.
Yeah.
yeah, do one and then immediately just almost copy and paste, do the other.
That's fine. That's interesting.
Are there things the iOS system versus the Android, do you notice they're significantly different, that you have to do things differently, or?
There are some pretty significant differences, like databases, for example. Swift data is coming out actually next week, which will greatly improve like on-device data storage, whereas Android doesn't have those updates just yet.
Thank you, Chief.
Yeah.
Excellent.
All right, and yours is just gonna start when I click it, right?
It's gonna go, yep.
Okay.
All right, it's going.
Yeah, it's going. I'm trying to get you full screen. Hold on.
So Python Pandas. Panda is the most popular, most used, I'll call it a non-standard library for Python. Largely used in data science and data analytics and those types of environments. And the mission, or the goal of this presentation, very lightly, and we'll say it this way, is to show you how to use pandas in a programming sense versus using a spreadsheet for some pretty common tasks. And I'll kind of talk about why one is better than the other, and some pros and cons here as we go through this. So Spreadsheet Pro is easy, right? Everybody knows how to use a spreadsheet. It's very visual. It's easy to share. Cons are size limits. I think you have something around 2 million, record size limit depending on version of Excel. If you're talking about Excel, obviously there's other programs out there that Excel's not the only one, but the most widely. When it comes to data frames, which is what a pandas creates in Python, a pro is it's Python. Obviously that's not a pro if you don't like to code. Very scalable, very repeatable. Cons is you have to code if you don't like to code. It's not visual, and it can be complex, which also can be a positive. I mentioned at the beginning that Pandas is the largest used external library for Python. In fact, when you see either new to Python, no matter what they end up using Python for, many of them come into Python in the first place because they want to do something in Pandas, or they want to do something in some other library related to it. Commonly used for data wrangling, data prep, ELT and ETL processes, so pulling data out of one source, putting it into a target. Data analysis, I use it more for doing alerts and checks and automation myself. I tend not to use it for those other things. Data sources, almost anything, but the common ones you'll see are CSV files, even JSON files, XML not so much anymore, but at one time. APIs, very common to see SQL relational databases, NoSQL databases like a MongoDB, for example, and Excel, a few others. So using it from the REPL is just the command line. You can use Python and an IDE as well. First you have to install Pandas, it's not there by default, then you have to run Python, and then the first thing you do is you'd actually import that library at the bottom there, and I'll just kind of show you a few examples. So you create a data frame, the data frame is in blue there where it says df_plants, and you would read an external source of some kind. I'm using an Excel spreadsheet here. Then you can actually just type in the name, it gives you the output, and actually you can look at the field values or the field information as well. You can also do things like sorting, which is pretty basic stuff in a spreadsheet, obviously. You define the actual fields you want to sort by, so you can sort by text, and the top example there, and the bottom example is an example of sorting by numbers. So again, very basic things that are obviously easy to do in Excel as well. Here's an example of adding a sum row at the bottom. So a little bit more complex when you start getting into some of these things, but this is something that maybe you could argue is easier, at least for a smaller data set in a spreadsheet. You're basically just using a thing called pivot table, a function, and you're telling it to add a margin and go through and do an aggregation at the bottom. You could do things like filtering. This is where it probably gets a little bit easier when you're starting to do things in Pandas versus a spreadsheet, because you do have limits and how you can do this in a spreadsheet, of course. A couple examples where I'm actually building a couple new data frames. There's one called outer rim, one called large. And then I'm actually going to use those in this example here to create sort of a data frame A to data frame B, data frame A is actually just taking the exact same data that was in the one's data frame and the same thing for the B, and then I'm adding a source field to each. So you'll see there's a source field equals A equals B. And now you can see those together where it says plants combined, COMB, moving fast. And you actually concatenate them together to do that, and then down below, I'm actually dropping all the duplicate lines so I can find the duplicate or the non-duplicate records between those two. Real world example, I had a large data, I'm just gonna let this slide live. I had a large data set where I had 4 or 5 million records, and there was no way I could do that in a spreadsheet, and it's just way too many records. And even if I could, you could do 2 million at a time, it would take forever. It runs a few seconds for a large data set like that in Python. So that's where you start getting into those examples. Obviously, you might want to write this result out somewhere. Here's an example of writing out to a spreadsheet, actually putting one data set in one sheet of a spreadsheet, another data set, actually the original data set in this case, into the other tab. And you can sort of see that there's 2 tabs there, but I'm just showing the first one. And then last thing, and this is not really how you would do it, you would actually do this as you go along, but all those data frames that I just created are all chew up memory. So if you've got 4, 5, 10 million records you're loading, every time you copy those things, you've got a huge amount of memory that you're chewing up. So you really want to put those lines throughout your code as you go through, but I didn't think it was real clear, just kind of throwing them in there as it went along. And that's it. I think I'm 4 minutes and something seconds, slightly less than 5 minutes. 17. Questions?
Have you seen this Panda concept brought into other languages?
Yes. Well, actually, to be honest with you, it was sort of stolen from R. So R has a concept of data frames as well, and it's much more native to R, although there are lots of third-party libraries that you typically use to do it. But I actually saw it in R before I saw it in Python. But Python, although Python is way more complex than R, and actually I would say harder to learn because R is super basic, you can do way more in Python. And once you get beyond just this kind of stuff where you actually want to start presenting things and building web apps and things like that, that's where Python goes way beyond what you can do with R. So there's other languages out there that do something similar, but those are the main 2.
JetBrains just released one for Kotlin, called Kotlin Notebooks.
I didn't know that. That's interesting.
Nice.
Any other questions? Yes.
I like how data frames, they could just output things back in the spreadsheet, because in the end, some of the data, especially when you're in meetings with managers, they need to see that visual, the spreadsheet.
Yep.
One other thing that I've done to kind of combat, in case I get questions, a lot of questions from left field and how to see the data through pivot tables and spreadsheets. Not too familiar with Panda. Is it able to kind of create pivots into the
Yes.
spreadsheet?
Actual
That you
pivots,
generate?
yes.
Oh,
The
that's
example
awesome.
I used there wasn't really a real pivot, but yes.
Okay.
And actually, the 3 areas where I use Pandas the most, so where you see people first learn it, they're doing it just to do some basic analysis and some basic kind of data analyst functions. But the places where I use it are in massaging data for financial applications, where you're taking one source, you're converting some other thing, and then you're sending it to some kind of financial processor. And a lot of times that's electronically, maybe not through an email, maybe through some kind of other method. So that's one. Another one is you're actually just transforming data from point A to point B, you're making some kind of change, format change to get something from one SQL source to another, to a SQL target. And then the other one is actually just looking at data and actually checking that second process I just talked about. We're actually comparing and trying to figure out where that fell or where it didn't fall, and actually having sort of a test version of that that's actually gonna be able to alert people that manage it to know that something didn't work or something didn't load correctly.
Does that library have a notion of relationship? Like this row of this table relates to that, or this column of this table relates to that column of the other table?
Not on its own. You can do that, and you can write code for it, and to be honest, there's a ton of things that people have written for Pandas, so my guess is there's probably something that isn't exactly what you're talking about, but not in Pandas itself. Although, I will say Pandas is going through a lot of changes right now. Pandas 2.0 just came out, there's a whole bunch of new stuff in it. Alright, thank you.
I had 2 questions for you.
Yep.
How do you think Panda's adoption rate is going to change now that Microsoft is porting or incorporating Python into Excel?
That's a good question. To be honest with you, I think if anything, you're just, it's just Microsoft sort of acknowledging that Python has that market share, that maybe not the market share, the mind share, if you will, out there for people going into analytics. So it probably makes you feel a little bit better if you're forced to work in a spreadsheet, to know that you can write something, a filter or something inside a spreadsheet and then reuse it later when you maybe get out of Excel. That's kind of how I do it. We'll see, but it's just my thought.
And Bill, there's hard limits with Excel, the number of files you can open, the number of tables.
Yes,
Things.
number of columns too.
Pandas solves that very easy. I mean, we deal with CSVs that are 20 gigs.
Yep.
Don't open that in Excel.
Yeah, and to be totally transparent, Pandas itself has limits, but there's a whole bunch of technologies built around Pandas that just get rid of all those limits too, so. Okay, cool. Thanks, guys.
All right, you ready?
I'm ready.
Okay, get this going.
Okay. I'm Michael Cheney. This is my picture. We're going to talk today about doing metaprogramming in Ruby. Now, there's my slide. Metaprogramming is code that manipulates code, okay, or code that writes code. This is at runtime, okay. It's not necessarily, compile time type stuff like it, you see. Why Ruby? Well, we use Ruby Ruby's very good for this because the entire, everything about it can be changed at runtime. It can also, anything can be altered, and you can also view what's going on inside your classes, your modules, and everything else. So we use these three techniques: reflection, introspection, and code generation together to do this. Now we have a real-world application, which is an ORM, Object Relational Mapping. If you ever use Ruby on Rails, they have a thing called Active Record that does this. But it's real easy to write a simple ORM. Basically, ORM it uses an OOP paradigm to interact with the standard RDBMS. Okay, and as I said, all modern frameworks include an ORM. Here's a really simple Ruby ORM that I call PG table, and it allows us to create an object, tell it what database table it's hooked up to, and then it creates attributes for, let me go through how I did it. You define the table real simply, just it looks like a declarative style, and we tell it what the table name is for our object, or the object we're going to create. And then it's going to create, using this wacky code over here, it's going to create attributes on the objects that it creates for each one of the database columns that it finds in the database. Let's see, each column name, that's what I just said. ChatGPT is messing me up sometimes. So yeah, each column name is used to create an attribute with a getter and a setter, which is like normal stuff, right? I create this find method. This is how everything works in Active Record. So you can go find a record based on the ID, and you can see the little bit of code there. And then you initialize an object based on the values that are passed into the initializer, which for find, it passes those in from the database table. But you can also just create like a new one and pass in attributes yourself. And then the other thing I did is I wrote a simple saver so that after you create or find a record in the database, you can go back and save it. Actually, this is a boring one. This only allows you to update, so you got to find it first and then do that. And then, what's this? Oh yeah, and then I wrote an inspect method so that you can see what your object kind of looks like. And this is a boring one. It's just a recipe for hamburgers. And then, the advantages. Here, let me go over here so I can read. This approach is dynamic, reusable, and reduces boilerplate code. Okay, which is really cool. Now there are disadvantages as well, and they're about to come up. There you go, caveats, be careful. This can increase complexity and debugging can be tough. That is so true. It is really, really difficult to test and debug dynamic code. When you have code that writes code, it kind of gets wacky. And so there are practical use cases, applications where repetitive similar tasks need to be optimized. This is so true. Basically, especially with an ORM sort of thing, you don't wanna have to create a class for every database table, you know, et cetera, write all the columns in there, and, you know, you're doing stuff twice, right? Metaprogramming has to be tested extensively, preferably with a set of automated tests. That is so stinking true, which is a lot like the caveats. And so you can learn more. There are a lot of books that talk about this. There are a lot of websites that talk about metaprogramming. A lot of the things I just showed you can also do in JavaScript pretty easily, and I think Python too. And there you go. That's me on the surface of Mars. Okay. Any questions?
Can you put the previous slide, 2 slides back?
Probably
Arrow
not.
keys.
Just try to arrow key.
Oh, that boy, yeah, that one. You like that one?
Got you.
Okay.
That's
I like me on
that was
Mars
it.
better.
Yeah, I think that's an amazing shot.
Yeah.
How much did it cost to go to Mars?
10 cents?
Yeah, 30 bucks a month, Mid-Journey. Yeah.
Just as like just to begin to understand Ruby as an language, what resource would you suggest?
Oh man, I don't even know. I mean, you can start off, you know, there's a good Ruby book. Obviously, there are a lot of websites. There's a very good Ruby book. There's always every time they come out with a new version of Ruby, they come out with a new book called the Pickaxe book, which kind of documents, you know, the entire language. But if you're coming at it from, I mean, those assume that you already know programming languages. The thing with Ruby is that the way that you write code in Ruby is very different than most other languages, or it can be at least. If you're familiar with like a lot of the new changes in JavaScript, I mean, a lot of the stuff in JavaScript, for instance, rather than using a for loop now, we use for each, like with an array, right? And so if you can get your mind around that concept, that Ruby really fits more into that paradigm. As a matter of fact, that's pretty much where all that JavaScript stuff came from. And so getting your head wrapped around doing things that way is really what, you know. And I don't know if you can get that from the Pickaxe book. There are other books. Another one I really recommend, which is actually an old book, it's 15 years old, but there's one called Design Patterns with Ruby. And so they took the standard old Design Patterns book and basically did it for Ruby. Very, very good book. Talks a lot about this sort of stuff and, you know, just different things like that. So, yes?
What are some common examples of metaprogramming outside of something like what you just showed us today?
Usually in library code, I mean, it's like if you're writing like a straight program, you're probably not going to be doing metaprogramming, or at least you probably shouldn't be. You're probably solving things the wrong way if you do. But when you're writing library type code, another good example I have, which is funny because it's like built on top of something like Active Record, is I'm like real anal in my programs about separating out different user types. And so I don't, common paradigm for user authentication and authorization is that you have a users table, and then each user has a set of roles associated with them, right? Or so this guy's a regular client, this guy's an administrator, whatever. I don't like doing that because I don't want for there to be any path between someone who logs in as a regular user and an administrator. I don't want them to be able to figure out how to upgrade their account or something, if that makes sense. So what I do is I have literally completely separate classes for regular user and administrator. The problem is that like 95% of the code is common between these two, right? Because you're doing the same sorts of things, logging in, logging out, whatever. That would actually be a really good place where you could come in and use metaprogramming on top of everything else to say, I'm gonna make a user class called administrator, and this is the database table they're going to use, and yada yada yada, and then generate automatically all the rest of the code that goes with it. But that code, this is the thing, there are code generators out there, which is a very common thing, but what we're talking about really is generating all this code at runtime. So it doesn't exist, you know, except when the program runs.
Does it have to be at runtime to be considered metaprogramming, or can that be compiled at other time?
I mean, for what we think of metaprogramming, yeah. So, anybody else? Okay, have a good one.
So I'm going to preface this one. This is 20 slides that Greg is actually going to do, but he has never seen these slides before at all. I actually made the entire slide presentation up for him, and so he's going to go up here and basically try to be like he's actually giving an actual talk on something, but hopefully it'll be inspired by whatever he sees here.
It's better than my talk next month.
We'll see. You could use this one. We'll be recorded. You could actually take it.
That's right, all right.
All right, so he has never seen any of these before, so this is all ad lib, you know. And I generated all these for him, so. If you, I don't know if you're easier to see this one. If
I think I'll try my best to see what I can see.
you can also see here
Oh,
too.
yeah, that's good.
Okay.
So I've been in QA for about 40 years, doing testing, no kidding. And, but I've learned some cool tricks along the way that I thought I would share. One cool trick I've learned in QA, see how many of those were coming. So, first it's just such a mishmash, you never know what you're going to get. So I tried this thing over here, the first event, I realized I had to revise, and I came to my second variation of what I thought was the best thing, but lo and behold, then the third thing came, but there's gotta be something better. And then I was in the garage using duct tape, and it struck me, this is genius. What could you do with duct tape that would apply to testing? And so I started kind of giving it some time, you know, ripping it, you know, shredding it in different ways. And then my poor wife, you know, I went out and smashed the windshield of our car. And I know she wasn't really thrilled with it, but I thought about the duct tape analogy and how I would use this along with this experience of smashing the windshield of our car. He wasn't really happy. But, you know, me being a QA guy, I thought, well, I'll figure this out. So first, I drew a graph up there just to impress her. I had put some time into thinking, and you know, that I had just smashed her windshield. She was very enamored by this experience here. She thought, wow, my husband must know what's going on. He's drawing all these graphs. This one's got a light bulb, you know, Edison, this must be smart. There must be something here to dig into. And so, going back to the duct tape. Let's see. Well, you have to have an input. So anybody who knows with duct tape, you have to rip it off, but you have to apply it somewhere. That's the input perspective, right? What am I going to apply it to? And who am I trying to basically shut up so they don't talk anymore? Google Translate app helped me a ton. And I had to repeat this thing in 90 languages, from German to Japanese, which is how do you say duct tape in those many different languages? Well, it came in very handy. So I sat down with my laptop. My wife's thinking, there's that chimpanzee again. He's working on his computer. He's always in that room typing away. And I thought, well, it's just one more click, honey, and then I'll be in for dinner. So I worked on it and worked on it. Thankfully, I had the duct tape. I had to go feed the pet turtle, the new pond I made. Thankfully, I had the use for the duct tape because I did have a small leak, and that duct tape came in handy. It kept those wheels turning. How was I going to apply this? Then the hammer came out. I knew it was hammer time. So I got that mallet, and I began to work in my shop in the garage, hammering away. Pieces were flying off all over the place. Some flew into the hole that was still in the windshield of my wife's car. And I thought, I know, the answer is automation. Automation solves everything, right? It's going to take away all of our jobs. It was really great to know that I worked in this space. At least that's what everybody said. And I got out the duct tape one more time and looked at it and thought, no, there's something wrong with this. There's some kind of fault. I don't know. Something doesn't line up. What could it be? So I gave it a little more thought. What could it be? You shall not pass. That's what it was. That duct tape was still something that seemed unpassable unless I ran with it with mighty activity to tear it apart. And still it said, you're not going to pass. I thought, but I have to do something. I have to pass. Because in testing, we're always seeking the thing that's going to pass the test. At least that's what I tell my students never to do. But it doesn't mean that they don't do it anyway. Because we really want to test, not just pass. But nonetheless. This is a team game. We need our managers, our developer, and most of all our QA engineers. They've got to come to the table. They've got to get past that mindset of everything's got to pass. And they've got to not forget to bring the duct tape to the game every time. QA, developers, scorching, searing sun type of heat. Something's going to help them refine the best quality they can get. It's got to be more than just duct tape. What could it be? Well, you come up to the whiteboard again and you appeal to people by drawing nice graphs like this. And you say, well, in 2004 there was gray duct tape, but they began to evolve it with other colors as time went on. We're almost there. Will they come out with rainbow? Will they come out with purple, my daughter's favorite color? Oops. No, it turned out that dye they used in purple caught on fire. So we decided to scrap that one. It just wasn't the right one to use. Still, the question exists. What about the duct tape? We figured it out finally. That was the question. That was the secret to the QA world. What did it say up there? When QA finally finds the problem that the purple dye is the problem, but there are other variations of purple that we can use. So thank you very much.
That's gonna go on YouTube.
Yeah. Thank you. That was completely ridiculous. I think I got one word that I'd probably stand by in that whole thing.
No questions?
Yeah,
Okay,
any questions?
jump in.
What was the analogy of the duct tape all about?
Yeah. Well,
Gotta find something. to
yeah, I
stick
had to find something to tie in with breaking my wife's windshield. Duct tape. Yeah, good question.